Okay, I'm going to do number 2. Frosty, a 500-kilogram snowman, is leading a parade through a local village. At the corner of an angry police officer orders him to come to a stop. Not wanting to get in trouble with the local law enforcement agency, he stopped walking forward and attempts to slide to a halt. Being made of snow and the conditions being rather icy, the kinetic frictional force of coefficient is only 0.0005. What is the net force acting on this frozen automation? Okay. Excuse me not being able to say words. Let's go ahead and find out what is the net force, what is the acceleration, and we have some looking like a kinematic here at the end. Now, the mistake everybody makes with Frosty the Snowman is giving him too many forces. Once Frosty stops applying a force forward, he no longer has a force forward. Once he begins starting to slide to a stop, he's applying all his force backwards. So he's Fn and Fg, and then he has just a tiny frictional force going back. Bam. Fk. I did a poor job reading this, but let's get what we need from this. I have a 500-kilogram snowman. Oh. At the corner, he comes to a stop. So his final velocity is going to be a stop. Okay. Not wanting to get in trouble with the law. You have the coefficient of kinetic friction is 0.0005. We want what is the net force. We want what is the acceleration. And we want what is the initial velocity. Now, let's just take the information we need for the kinematic. I'm going to put that in white here. So I'm going to have VF there. We'll make that an extra problem at the bottom here thereafter with white. So I have a VI. That's what we're looking for. Where is he starting? We know his final speed is 0 because he comes to a stop. Oh, wait. It says his initial velocity. Sorry. His initial velocity is 3. How long does it take to come to a stop? We're looking for t, and we're going to be getting the acceleration from the problem above. Okay. So I've drawn my free body diagram. Now it's time to draw the sum of the forces in both directions. Sum of the forces in the y direction is Fn minus Fg, and we're going to assume he doesn't pop up off the ground or fall through the ground, so that would be a 0. The sum of the forces in the x direction are the forces right minus the forces left. There's 0 forces going to the right, so minus Fk going to the left. I put a 0, but that's not true, right? He's accelerating. He's equal to max. All right. So we have here that the sum of the forces in the x direction is equal to negative fx. So it's asking us to solve for the sum of the forces, so we're going to go ahead and do this. Negative fx, instead of that, I'm going to put negative mu k times fn. I'm going to put fn in red because I know we need to go to the right equation to solve for it. Going to the right equation to solve for fn, we would just add, we have fn minus fg equals 0. I'm just going to add fg on both sides. So I get that fn is equal to fg. Unfortunately, I don't know fg, but I do know m. So I'm going to go to my calculator.